Hello students, today we shall be doing ethers. As you know, ethers are alkoxy-alkene. They have the same general formula as that of alcohols. Ethers are represented by the formula RO R dash. If R and R dash they are same, we call them symmetrical ethers, and if they are different, then we call them unsymmetrical ethers. Now normally what happens? The smaller alkyl group is prefixed with oxy and the bigger alkyl group is ended with "ane". That means alkoxy-alkene. So here the first example you have taken when both the alkyl groups are same across oxygen. So IUPAC name is methoxymethane and common name is dimethyl ether. Second member where we introduce one CH2 here. So it is methoxyethane, as methyl group is smaller than ethyl group, so it has to be alkoxy. Methoxyethane and common name is ethyl methyl ether, where you have to follow alphabetical order. The third member onwards you start getting isomers. So since the first compound on both sides you have the same group, then it is ethoxyethane, because either way it can be alkoxy or alkene, and common name is diethyl ether. But when we distribute 3 carbon in one side and 1 carbon on the other side, then this group becomes small group, so it will be alkoxy, and this side will be alkane. So it will be 1-methoxypropane, it should be a single word, and common name will be methyl N-propyl ether following alphabetical order. Second one also, we have 3 carbon chain on one side and 1 carbon on the other side. So this is becoming your alkane and this is your alkoxy, but the position of the alkoxy group is in carbon 2. So it is 2-methoxypropane and common name is methyl isopropyl ether. Okay. So when we assign alphabetical order, remember we do not consider this iso as given priority alphabetically. Now what is the relationship possessed between the 3 compounds? These two, as you can see, they differ in distribution of carbon across the oxygen. Here the distribution is 2-2 and here distribution is 3-1. Such isomers are called metamers. And here again these two, when both have 3 and 1 distribution of carbon, then they are position isomers. As you can see, one is 1-methoxypropane, the other is 2-methoxypropane. So please remember 1, 2, AB and AC, they are metamers, whereas BC are position isomers. Then we take up some more example. The aromatic ether, first one is benzene ring with a OCH3 group called methoxybenzene, or commonly called anisole. Anisole is also accepted by IUPAC. And second example you can see here, where we have 7 carbon this side and benzene ring has 6 carbon. So this becomes parent group. So name becomes 1-phenoxyheptane. Okay, not 1-heptoxybenzene. Remember that. Now when you have this example, please ignore this double bond. You can see here one of the carbons have methyl group and the other carbon has methoxy group. Now which carbon will be assigned position 1? Out of methyl and methoxy, you can see alphabetically methoxy comes before methyl, the first point of difference being O and Y. So methoxy has to be given position 1 and carbon bearing methyl group should be assigned position 2. So it will be 1-methoxy 2-methyl cyclohexane. However, when we have a similar example, here you can see we have 2 methyl groups and here we have 1-methoxy, then we do not go by alphabetical order. We consider 2 substituted carbon which is having more number of hydrogens being substituted here, that carbon gets higher priority and assigned position 1. So it becomes 2-methoxy 1,1-dimethyl cyclohexane. Please check while naming, we have to name the methoxy first because that is coming alphabetically first.